Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we're going to be solving a Renban Sudoku called Nine More Squares by Philip Newman. And indeed, there are 9 extra squares in the grid to go with the 9 square regions that we already have in a standard Sudoku. So this is a Renban Sudoku. So we do have standard Sudoku rules, replacing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And in addition, we have some Renban lines. So these lines, these purplish lines, indicate that the digits on the line have to form a set of consecutive numbers, but those numbers don't necessarily have to show up in order. For example, we know there's a 3 in this set of consecutive numbers, so normally without any other info, it could be 1, 2, 3, and 4 in any order, it could be 2, 3, 4, and 5 in any order, or it could be 3, 4, 5, and 6 in any order. As long as it contains a 3, the order doesn't matter, and we don't know exactly what set it is. But because we know here that there's already a 2 in the region that's not on the Renban, this has to be 4, 5, and 6. And similarly, this has to be 3, 4, and 5. So we know our remaining digits here. 1's got to go there because 1 eliminates 1 from these 2 cells. This is going to be a 2-9 pair. 8 can only go here, and these are going to be a 7-9 pair. Now, that's not a 6 because there's a 6 right here, and that's not a 3 because there's a 3 right here, and that means in the column the 2 remaining digits are going to be 2 and 7. Okay, so that's a good start. So we have a 1 and an 8 here. 2, 3, 4, 5, 6, 7, 8. This is 8 cells in total. Therefore, it has to have the digits 1 through 8, since we know it has a 1 on it. Now, none of these guys can be 2 or 7, so the only places to put the digits 2 and 7 on this kind of big square here is going to be outside of the central region, so here and here. And so the remaining digits have to be 3, 4, 5, and 6. That means the last 2 digits here are 1 and 8, which go in that order. And these guys are going to be 3 and 6 to finish off the row. All right, let's take a look up here, shall we? So we know that there is a 2 here because there are 2's in rows 2 and 3. This Renban has to have a 2 on it. It can only be 1, 2, 3, 4. So 2 will go right there. In fact, because we have this 3 here, we can place a 3 right there and make that a 2-4 pair right now. Now we have 1's here and here, which means that 1 has to go up here. So this Renban, which has a 2 on it, can't be 1, 2, 3, and 4, so it must be 2, 3, 4, and 5. The 4 is eliminated from these cells by the 4 in column 9, and that's going to be a 3, 5 pair. Similarly, we have 8's here, eliminating 8 from this Renban with a 7. So it can't be 6, 7, 8, 9. It can't be 5, 6, 7, 8 because those both have 8's, so it must be 4, 5, 6, 7. There's a 5 right here, making that a 4, 6 pair, and placing a 5. Now those two 5's give us a 5 right here. And these two 4's are going to give us a 4 right here, because 4 cannot share a 4-cell Renban with 8. The lowest that 8 Renban can possibly go is down to 8, 7, 6, 5. So it could maybe have a 5 on it. It definitely does not have a 4 on it. So what the 4 does is it resolves this 4, 6 pair, just as the 5 up here resolves this 3, 5 pair. These digits are going to be 6, 7, and 9. In fact, the only position for 6 in this region, because of the 6 right here in region 7, is going to be right there. This can't be a 9 because there's a 9 there. That makes that a 7, which resolves the 2, 7. And this is now a 9. Now up here we need 7 and 8. And down here we need 1, 2, and 3 to finish the column. This can't be a 1 because 1 can't share with 5. These are going to be 2, 3, and 9. This can't be a 9, that can't be a 3, that can't be a 2, just by Sudoku looking at the columns. We have a 5 here now, which resolves this into a 4 and 6, and so this is 7, 8, or 9 to finish the row, but we already have a 7 and 9, so that's going to be an 8, which resolves the final digits in row 2. Here we need 1, 6, and 9. That's not going to be a 9. These are going to be 1, 3, 5, and 6 to finish the column. 1 and 3 definitely can't go on this Renban with the 8, so this is going to have to be a 5, 6, 7, 8. And that'll be a 1 with a 3 there. The 3 resolves this into a 6, and that's now a 3. So this Renban must be 2, 3, 4, 5, because it includes both 2 and 3, and also 5. So that's a 4. This is now a 1, and that's going to be a 3. And Sudoku takes care of a few things for us there. Those can't be 1s. There's a 6 in this column, so this is going to be a 9. These guys are 1, 5, 7, and 8. We definitely can't have a 1 here. There must be a 5 because we have to somehow get between 4 and 6, and we have to have a full consecutive set, so because 5 is between them, it has to be on this line. But it's not in this position because there's already a 5 in column 9, so that is our 5. That's going to be our 1. These guys can't be 3 or 5, so these guys can't be 4 or 6. The 2 here gives us a 7 and a 2, which resolves that. I suppose that's also resolved by the Renban. And now what? So over here, we still need an 8 to finish off this row. Here we need a 6 to finish off this row. We have a 4 there that resolves the 2, 4 pair. That's now going to be a 9, and these are going to be 1 and 8. The 4 resolves this Renban, giving us a 5 and a 3, placing a 4 right there. The 5 resolves that. The 9 in row 9 resolves this, and then our last digits here are going to be 1 and 2. And let's just finish up. 3 and 4 there. Tell us which way around these go. And that is how you solve Philip Newman's lovely 9 more squares. Hope you enjoyed that one. I definitely did. To check it out yourself, there is a link to Sudoku Pad and to F puzzles in the description below this video. And I will catch you again in a couple days.